Hello girls, I hope you're staying safe at home. To continue with electrolysis chapter, today we are going to discuss some examples of electrolysis. First, let us talk about electrolysis of molten lead bromide. So electrolyte used is molten lead bromide and the temperature is maintained above 380 degrees Celsius to keep the lead bromide in a melted state. Okay, so this melting point of lead bromide is maintained by continuously heating by a burner. The electrolytic cell used is a silica crucible. So why is silica used? Because it is non-reactive, it can withstand high temperature 380 degrees Celsius, and it is a non-conductor of electricity. So this crucible is heated slowly from outside by using a burner. Now you know solid lead bromide does not conduct electric current because it does not have free ions to carry electric current, because the ions are held together by electrostatic force of attraction, the ionic bond between them. So the ions are free when lead bromide is in the fused or molten state. So the crucible is heated continuously from outside to keep the lead bromide in the molten state. Okay, now the electrodes used are made up of graphite plates, which are inert electrodes. So if you remember in the beginning, I had told you the electrodes may be either active or inert. Active electrodes, they take part in the reaction, but inert electrodes do not take part in the reaction. And the graphite plates or the electrodes are connected by means of copper wires to the two ends of the battery. Now since it is lead bromide which is in the melted state, there are only two ions present, lead ions and bromide ions. Now you know the lead ions, positively charged, will move towards the negative electrode, that is the cathode. So it had turned into an ion by giving away two electrons, which it will regain. Two electrons will be added to it and it will become an atom of lead. And at the anode, you know, the negative bromide ions will go towards the anode, and there it had become negative. Why? By accepting one extra electron. So that extra electron must be given away. So minus one electron and you will get one bromine atom. So two bromine atoms at the anode will come together to form bromine gas, and you know the color of bromine gas is reddish brown in color. So this is the overall chemical reaction that is taking place. Lead bromide, it breaks down into lead and bromine. Okay, so what do you observe? Observations in chemistry, you know, children, are very important, because you may get one whole question based on that. What do you observe when molten lead bromide is electrolyzed? So what will your observation be? Dark reddish brown fumes of bromine evolved at the anode, and silvery gray metal lead. The color of lead is silvery gray, is formed at the cathode. So what happens when the current is turned on? The positive lead ions will migrate towards the cathode. They take up two electrons, as I had already explained, and become neutral lead atoms. The negative bromide atoms will move towards the anode, give away, it will give an electron each and become bromine atom. So these two atoms combine to form bromine gas. There is a reason for using graphite electrodes in the electrolysis of molten lead bromide. Why? Because if platinum electrodes are used, they are affected by the bromine vapors which is released at the anode. So graphite is used. Why? Because a graphite anode is not affected by the reactive bromine vapors. Now next, moving on to the electrolysis of acidified water, and platinum electrodes are used. So the electrolyte is acidified water. And why acidified? It is acidified with a little bit of dilute sulfuric acid. Now remember, dilute sulfuric acid is used. Why? Because it is non-volatile. While dilute nitric acid or hydrochloric acid, you know, they are volatile acids. Now electrodes, you already know, platinum foils are used. They are inert and they are connected by copper wires to the two terminals of the battery. Now How does water get ionized? Now, pure water is a non-conductor of electricity. It is made up of only molecules. But you know that water is a polar covalent compound and can form ions. And especially when traces of dilute sulfuric acid is added, more ions will be formed. Now, dilute sulfuric acid catalyzes this ionization. That means it helps the water to turn into ions. So, electrolysis of acidified water is also known as the catalysis reaction. It is an example of catalysis reaction. Now, what do you find in the electrolyte? Which ions do you find in the electrolyte? Water will ionize into hydrogen ions and hydroxyl ion. Sulfuric acid will ionize into hydrogen ion and sulfate ion. So the particles that are present in solution are three ions, that is hydrogen ion, hydroxyl ion, sulfate ion and water molecule. So these are the particles which you see in the solution. And if someone asks you which ions are present, you will say hydrogen, hydroxyl and sulfate ions. So hydrogen ions are the only positively charged ions that you see here, so they will migrate towards the cathode. Now, you know cathode contains a lot of electrons, and hydrogen ion had turned into a positive ion by losing its only electron. So it will gain back that electron. So hydrogen will gain back the electron at the cathode and turn into one hydrogen atom. Now here what happens? Two hydrogen atoms will come together to form hydrogen gas. And what happens at the anode? There are two negative ions, that is sulfate and hydroxyl, two anions, which will both migrate towards the positive electrode, that is the anode. And hydroxyl is lower in the electrochemical series, so it will be discharged preferentially. Now hydroxyl ion loses one electron. It had turned into a negative ion by gaining electrons. So that extra electron it will lose to the anode and it will turn into a neutral hydroxyl atom. So here hydroxyl it will lose the electron and it will turn into hydroxyl atom. That is, this electron has been given away. Now, when two hydroxyl ions come together, when two hydroxyl atoms come together, one hydrogen from here, it will go and combine here to form H2O, that is water, and then this hydrogen will be left alone to form the oxygen atom. So two atoms of oxygen will come together to form oxygen gas. Now, remember children, sulfate ions, they migrate towards the anode. Hydrogen ions, they become discharged, they are given away. Okay, so the concentration of sulfuric acid will decrease at the cathode. So if you are asked why, explain why there is decrease of sulfuric acid at the cathode. So this will be your answer. Now at the anode, what happens? The discharge of hydroxyl ions disturbs the ionic equilibrium of water. So to maintain that, more water will ionize. That means water will turn into hydrogen and hydroxyl ions to balance the equilibrium of water. Now the excess of hydrogen ions which is produced and the sulfate ions present increases the concentration of sulfuric acid at the anode. Okay, please remember that the acidity at the anode and cathode is not affected, and the overall reaction just involves the decomposition of water. Okay, so what happens at the anode? There is decrease in concentration of sulfuric acid, and what happens at the anode? There is increase in the concentration of sulfuric acid. So remember, there is decrease in acidity at cathode and increase in acidity at anode. If you're asked why, you'll have to explain this. Now, ratio of hydrogen to oxygen is 2:1 by volume. Now, if we look at the electrolysis of acidified water, at the anode, hydroxyl loses one electron and becomes neutral atom. okay, and OH combines to form water and oxygen. So how many? 2 and 2 come together to form total 2 molecules of water and 1 molecule of oxygen. Because if we take just one OH plus OH, it is giving us H2O, and 1 is being left alone, oxygen. So 1 atom of oxygen. So oxygen plus oxygen atom will form, okay, so this 1 extra oxygen atom is coming from another reaction between 2 hydroxyl atoms, isn't it? So H2O plus O and O plus O. So this O and this O, they are coming together to form this oxygen. So here how many molecules of water is formed? 1 here and another 1 here. So 2 water molecules and 1 oxygen molecule. So altogether, how many hydroxyl neutral particles are involved? 1, 1, 2, 3 and 4. Okay, so here total 1, 2, 3, 4 hydroxyl ions are producing 2 molecules of water and 1 molecule of oxygen. Okay, so 4 hydroxyl neutral particles are involved in the equation. So 4 electrons are lost altogether in order to get 4 neutral particles. Okay, so in the formation of 1 molecule of oxygen at the anode, how many electrons are released? 4 electrons are released. And there is no buildup of electrons in any part of the circuit. So the reaction of the cathode must take up how many? 4 electrons, because 4 electrons were lost. So how many electrons will it take up? It will take up 4 electrons. So 4 hydrogen ions will take up 4 electrons to form 2 molecules of hydrogen. So this shows that the number of molecules of hydrogen is twice that of the oxygen molecules, because if we go up here, you'll see 1 molecule of oxygen is formed, and here how many molecules of hydrogen is formed? 2 molecules of hydrogen. So according to Avogadro's law, molecules you've already done is substituted by volume. So electrolysis of water gives 2 volumes of hydrogen and 1 volume of oxygen. So that is what you get when you balance the equation as well. Next, we move on to electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode. Now, the electrolyte used, is the saturated solution of copper to sulfate, and this saturated solution is prepared in distilled water, and a little bit of concentrated sulfuric acid is added to increase the electrical conductivity of electrolyte. Now, since the copper sulfate is aqueous in water, the ions that you are formed are copper ions, sulfate ions from copper sulfate, and from water, hydrogen and hydroxyl ions. Okay, and the particles that you find are copper, hydrogen, sulfate and hydroxyl ions and water molecules. These are the particles that you find. Okay, so please remember to differentiate between particles and ions. Now what happens at the cathode? The copper and hydrogen ions will migrate towards the cathode, and if you look at the activity series, copper is below hydrogen, so copper ions will be discharged here in preference to hydrogen ions. And what is formed? Neutral copper atoms are formed. This is reddish pink or pinkish red in color. Okay, so copper ions will gain the 2 electrons it had given away to form copper atoms. So the copper atoms deposit themselves on the cathode. The metal will deposit itself on the cathode. What happens at the anode? Sulfate and hydroxyl ions will migrate towards the anode. The hydroxyl ions, being lower in the electrochemical series as compared to sulfate ions, will be discharged to form OH radical. The neutral OH radicals reunite to form water and oxygen, as I had already explained when I explained the electrolysis of water, how 4 hydroxyl ions loses the 4 electrons it had gained to form 4 neutral hydroxyl atoms or radicals, and 2 hydroxyl and 2 hydroxyl radicals will come together to form 2 molecules of water and 1 molecule of oxygen. So what is the product at the anode? It is oxygen, and product at the cathode is pink or reddish. Please do not use brown. Pink is very important, okay, is deposited. Now when the deposition of copper is complete, what will happen? Electrolysis of water will start taking place, and hydrogen gas will be liberated at the cathode and oxygen is liberated at the anode. A very important thing you must remember in this electrolysis is a copper sulfate solution is blue in color, okay, and the blue color of the solution is due to copper ions in the electrolyte solution. So as these copper ions loses their or gains the 2 electrons that it had given away and turns into copper atom, what will happen? The blue color of the electrolyte solution fades. Why? Because there is less copper ions, and finally the solution becomes colorless because all the copper ions are finished. That means all the copper ions turns into copper. So what will happen to the solution? It will become colorless. Why? Because the blue color is due to the presence of copper ions. We are again going to learn the electrolysis of aqueous copper sulfate solution only, but we are using different electrodes, that is copper electrodes. Copper electrodes are active electrodes. They will take part in the reaction. So electrolyte used is aqueous copper sulfate, and the electrode, as I've already told you, both cathode and anode are copper, active electrodes. So copper sulfate dissociates to form copper ions and sulfate ions. Water dissociates to form hydrogen ions and hydroxyl ions. So there are 4 ions present: copper, hydrogen sulfate and hydroxyl ions. Now what happens at the anode? Copper atom loses. This copper is the anode, the active anode. Okay, the active electrode. It loses 2 electrons and turns into copper ions. Now sulfate and hydroxyl ions, you know, they will migrate towards the anode, but none of them are discharged. Why? Because the anode is active, because of the nature of the anode. Now copper can lose electrons more easily than sulfate and hydroxyl. Okay, so copper ionizes to give copper ions. What happens at the cathode? Copper ions gains the 2 electrons that it had lost when it formed ions and turns into copper atom. Now both copper ions and hydrogen ions migrate to the cathode, and you know copper is below hydrogen in the electrochemical series, so they will be discharged as neutral copper atoms by accepting electrons. So what product do you get at the anode? You see that the copper anode will keep on dissolving during the reaction because copper ions are formed, and the product at the cathode is pink or reddish pink copper is deposited. Now sometimes the electrolyte aqueous, that is copper sulfate, is acidified with traces of dilute sulfuric acid to increase the conductivity. Okay, now here you will see that the blue color of aqueous copper sulfate does not change. It remains blue throughout. Why? Because at the anode the copper electrode is dissolving to form copper ions, and you know the blue color of copper sulfate is due to the presence of copper ions. So since continuously, even when the copper ions are forming, copper metal at the cathode, but what is happening at the anode? There is continuous addition of copper ion. So as a result, what happens? The blue color of aqueous copper sulfate solution remains unchanged during its electrolysis due to copper electrodes. Okay, so remember here, hydrogen ions, sulfate ions and hydroxyl ions are not taking place in the electrolytic reaction, and they are known as spectator ions. That means they are just there watching the reaction. Okay, children, this is all for today. For your assignment, I would want you to do the reactions at the cathode and anode of the electrolysis of molten lead bromide, acidified water, and copper sulfate using both platinum and copper electrodes. Okay, and you submit it as usual day after tomorrow in your usual time. Till then, children, stay safe. God bless.